So I guess I can easily skip my introduction. It's a very narrow subject I've chosen for my presentation today, but it's pretty important at the same time. It's common knowledge that Russia wants and actually needs to increase the carbon sequestration capacity of its forests. And indeed, Russia accounts for 20% of global forest cover, which means that whatever measures we are taking or planning to take need to take into account the spatial heterogeneity of carbon budget, because, in different regions, it's pretty different, both statically and in evolution. So I'm presenting here some of recent studies on this subject. Like I said, carbon sequestration or carbon sink capacity of forests depends on several factors. One is the age composition and species composition of the forests. And there are key factors which impact the evolution of this potential. One is, fires naturally, and other disturbances, so to speak, such as, for example, pests and insects, but also they can be maybe, illegal felling and what have you. Illegal and legal felling, in fact.
Здесь была следующая. Мы попытались оценить текущую эффективность использования.
Here we decided to assess the current effectiveness of using the available resources in the forestry sector with the objective of maximizing carbon sink capabilities in order to understand which regions we should prioritize if we want to live up to our NDCs under Paris agreements. Our observations span 2009-2018. We would love to expand it, but unfortunately our statistics is limited. And an important constraint for this study is that although the model I'm going to introduce here should ideally be kind of based on the assumption that, federal agencies, federal executive bodies are actually trying actively to manage carbon budgets, it probably goes without saying that in reality, and particularly in the year shown here, they didn't do that. They had other priorities. Well, this, however, doesn't stand in the way of doing post hoc studies or assessments or development of a methodology for doing it in the future. So we used here pretty well-known tools from the world of linear programming. It's often called data envelopment analysis. And this is the methodology first offered by Charles Cooper and Rhodes in 1978, but significantly developed since then. So here we're using various methods of LP in order to identify best combinations of resources in order to produce goods or services for a particular bunch of agents. So, for example, if our economic agents are regions and our resources are resources of the forestry sector, this is actually a nearly perfect application for such a tool. Now, most cases of DEA usage or data envelopment analysis usage were performed in the banking industry, and only 1% of studies focused on the forestry industry. I guess this is the first time it is being used for Russian forestry. And here we're using a separate standalone version, SBM version of DEA, where we calculate SLEX. Here we're actually looking at potential improvement in effectiveness through redistribution. So we can actually calculate efficiency for different agents. And you remember that in our case, agents are regions. And then we can calculate the potentials. That is how much we need to increase or reduce consumption of individual resources in order for the given region to be more effective in terms of how they use those resources. This is, the technical and mathematical advantages. SBM models use non-radial approaches, which sort of is based on the assumption that slacks are independent for various variables, various indicators, which means that changes in inputs and outputs of these models can be disproportional. This is a very important assumption for us because given high spatial heterogeneity, these impacts will be different. For data points, we went to Russian roster or register of GAGs for 2009-2018, as well as Rosleshoz and Rosstat data. Now, the LP problem is actually shown here, and it's actually a typical linear programming model, though with some minor modifications. These are the characteristics of the dataset that we used. As our inputs, we looked at salaries of regional agents, as well as budget allocations, as well as total length of mineralized strips that I guess protect against forest fires. Actually, the square kilometers destroyed by forest fires and falling in thousands of cubic meters. As output, we had forest carbon budgets. The non-parametric nature of this model enabled us to, well, elegantly sidestep some of the issues we had. Shown here is the spatial distribution of carbon budgets effectiveness. So 0 or very light colors is 0 efficiency, and 1 is absolute effectiveness. And 1 obviously corresponds to very dark green color. Obviously, we should not use these assessments to reward the more effective regions or find the less effective ones. It's the potential that we are after here. Here we have also grouped regions by relative effectiveness. For example, you should see that Western Russian regions seem to be much more effective. And one of the reasons for that, I guess, is the intense fires and pest issues in Siberian forests. This is obviously a major factor of forest degradation in the eastern part of the country. Although money is allocated towards protecting, preventing, and fighting fires, they are obviously not enough. They're not really helping much. Now, we see that top 25 most forested regions and 75% of, well, the remaining regions, so to speak, are pretty comparable in terms of effectiveness. And this study is not really complete. I mean, we can slice and dice this data differently and analyze different clusters if you have ideas for that. I will be happy to engage you in a discussion like this. Now, let me briefly cover the results. The transient current results as we see them. Spatial distribution of effectiveness is not homogeneous, which is something that we knew all the way, but we wanted to illustrate it. The effective regions include regions which actually have few forests. Well, obviously, if they don't have many forests to start with, they won't be doing much logging or felling, and they will be usually doing better protection. But also, there are some very much forested regions which tend to have high effectiveness, and they include Irkutsk region and Sakha Republic. We're not entirely sure why this is the case. We need to study in more detail the interplay of different factors. The effective regions, and I am showing them sort of in brackets here, are actually spending more resources than others, and they're actually getting less for that. And they are quite heterogeneous. They include, for example, Krasnoyarsk region, which is where I hail from, as well as Rostov region, which has very few forests and is in fact a steppe region. Russian regions here have demonstrated varying effectiveness in carbon management. And we actually see great differences even inside Siberia. We have ideas about why this could be the case, but in the meanwhile, we need to stress that, well, carbon sink capacity management is still not considered a priority by Russian forestry agencies. They're still trying to maximize the amount of precious timber produced, as Natalia correctly pointed out. And naturally, we are paying for that. If we are ineffective as we do reforestation, we should not be surprised at the results. So the discovered inefficiencies should not lead to reduced budgets for forest protection. The situation is not that bad there. Actually, current budgets for forest management in Russian regions are, in any case, pretty low, and they need to be stepped up. Unless federal government starts allocating more money to forest protection, Russia will not be able to live up to its commitments. Very briefly, I'd like to thank Russian Science Foundation for the financial support. And we're also grateful for some of the funding to the Center of Forest Environment and Forestry Productivity under the aegis of the Russian Academy of Sciences. And we're thankful to our partners for various discussions around it. Thank you very much, Anton. So let's get out of the woods and turn to another very important factor of our climate agenda. Let's talk the power sector. And here I would like to invite a deputy head of Energy Research Institute, Fyodor Veselov. Fyodor, I see you there. Please take the floor.